What is meant by one-to-one correspondence?
A one-to-one correspondence means just what it implies, that the number of objects, numbers, or whatever is the same as the set of other objects, numbers, or whatever. In set theory, the one-to-one correspondence means something different. For more about set theory, see Foundations of Mathematics. Everyone has no doubt had contact with one-to-one correspondence without even thinking about it. For example, there is a one-to-one correspondence of the number 10 to the number of fingers on both hands, 10. Counting a deck of cards is a one-to-one correspondence each number from 1 to 52, representing a card in the deck. When you compare two decks of cards, putting the cards side by side to equal 52 in each deck can also be considered a one-to-one correspondence. Not everything is counted in such a way. For example, when mathematicians want to know the size of an unknown quantity, they put the unknown quantity in a one-to-one correspondence with a known quantity.
What are some physics fields that rely heavily on mathematics?
Almost every field of physics, especially modern physics, relies heavily on mathematics. For example, mathematics is needed to understand the concepts of acceleration, velocity, and gravitational forces. Statistical mechanics also uses an intense amount of mathematics. And it is impossible to comprehend quantum mechanics without a good knowledge of mathematics. In fact, the subject of quantum field theory is one of the most mathematically rigorous and abstract areas of the physical sciences.
What is the fundamental theorem of the calculus?
The fundamental theorem of the calculus is the connection, or, more accurately, the bridge, between the integral and the derivative, in other words. It is another way of finding the area under a curve, see above, by evaluating the integral. In particular, if f, x, is a function whose derivative is f, x, then the area under the graph of y equals f, x, between the points a and b is equal to f, b, f, a.
Has mathematics been used in art?
Yes, mathematics has been used in art either consciously or not over the centuries. Many of the fine arts deal with trying to comprehend the reality around us. And because both art and math try to explain reality using some concrete or abstract elements, it's easy to see the connection. For example, there are some obvious relationships between art, especially painting, and mathematics. An observer can use geometry to analyze a painting in terms of shapes. such as lines, points, circles, or other geometric shapes. Perspective can also be thought of as a mathematical quality of many realistic paintings, allowing the viewer to see reality, in the case of a painting, in 2 dimensions. And, in a way, Jackson Pollock's method of literally throwing paint on a canvas can be thought of in terms of fractal geometry. Mathematicians may work with quantifying and counting, but most of them will tell you that math is really more than a technical exercise and juggling numbers. Creativity is involved in discovering nuances in certain mathematics, with the mathematician creatively deciding what to concentrate on in order to solve certain complex problems. Just like a picture. Mathematical concepts need to be created, invented, and discovered, much like the French painter Claude Monet, and others, invented Impressionism.
What are some examples in which probability is used?
There are thousands of examples in which probability is used. Some are familiar, and some originate from the seamier side of life. For example, everyone has played at coin tossing at one time or another. Although there is no such thing as an idealized coin, a circular one of 0 thickness, most coin tosses use the coins available, with either side face up. Heads or tails, also phrased heads up/down or tails up/down. Thus, one can think of a coin as a 2-sided die in lieu of the 6-sided cubes we are all used to in a game of dice. If a coin is tossed with a good amount of spin, we can denote the 2 possible results as H for heads and T for tails. If we repeat the tosses n number of times, we obtain n, H, heads and n, T, tails. Thus, the fraction of n, H/n and n, T/n can be thought of as the chance probability, to get a head or tail, respectively, P, H, and P, T, are the most common notations that represent the probability to get heads and tails, respectively. If we toss the coin many times, the result should be close to 0.5. Of course. This means that if we bet on the chances of heads and tails, we will not be much of a winner if we play too many games, and we will have to have really good luck to win if we play fewer games. Chuck-a-Luck is a gambling game that has been played at many carnivals over the years. It involves a player who may bet on any one of the numbers 1 through 6. Based on 3 dice placed in a cage. If a selected number appears, the gambler gets paid even money, if one of the numbers comes up twice. The gambler gets paid 2 to 1, and if the desired number comes up 3 times, the gambler gets paid 3 to 1. But if the player worked it out, he or she would find that the game's expected odds are worse than for almost any other table game of chance. The game is sometimes used as a fundraiser for charity. But the odds of coming away with more money than originally put in are quite small. and they are even worse if someone has loaded the dice. Probability can also be associated with the violent game of chance called Russian roulette. In this bizarre sport, one or more of the 6 chambers of a revolver are filled with bullets. The magazine is rotated at random, and the gun is fired at the player's head. The risk taker bets on whether or not the chamber that rotates into place will be loaded. If it is, he loses not only his bet but also his life. Not to be outdone, there are people who have come up with a modified version of Russian roulette. In this case, the gun is loaded with a single bullet and 2 duelists alternately spin the chamber. Each duelist fires at the other until one is killed. The probability of the first duelist being killed is 6/11.
What are some more recent philosophies of mathematical logic?
Mathematical knowledge and logic in the late 20th and early 21st centuries has been greatly impacted by the development of predicate calculus and the digital computer. Out of these ideas, not to mention centuries of mathematics and logic groundwork, come 3 of the latest philosophical doctrines of mathematical thought. Formalism is the idea that mathematics is truly formal, therefore, it is only concerned with the algorithmic manipulation of symbols. In formalism, predicate calculus does not denote predicates or anything else, meaning mathematical objects do not exist at all. This definitely fits into today's world of computers, especially in the field of artificial intelligence. But this philosophy does not take into account human mathematical understanding. Not to mention mathematical applications in physics and engineering. Constructivism was a fringe movement at the turn of the 21st century. Constructionists believe that mathematical knowledge is obtained by a series of purely mental constructions, with all mathematical objects existing only in the mind of the mathematician. But constructivism does not take into account the external world. And when it is taken to extremes, it can mean that there is no possibility of communication from one mind to another. This philosophy also runs the risk of rejecting the basic laws of logic. For example, if you have a mathematical problem with a yes or no nature, and the answer is unknown, then neither yes nor no is in the mind of the mathematician. This means that a disjunction is not a legitimate mathematical assumption, and, thus, ideas such as Aristotle's law of the excluded middle, either or, are cast aside. Not many modern mathematicians want to throw out centuries of logic. Set theoretical Platonism sounds as if mathematicians are regressing back to Plato's time. In reality, this philosophy is based on a variant of the Platonic doctrine of recollection, in which we are born possessing all knowledge, and our realization of that knowledge is contingent on our discovery of it. In the set theoretical Platonism, infinite sets exist in a non-material, purely mathematical realm. By extending our intuitive understanding of this realm, we can cope with problems such as those encountered by the Gödel incompleteness theorem. But this philosophy, like the others, has a seemingly infinite number of gaps. Especially the question of how a theory of infinite sets can be applied to a finite world.
What is the Pauli exclusion principle?
Quantum theory also relies on the Pauli exclusion principle. This principle, developed by Austrian-born Swiss physicist Wolfgang Pauli, 1900 to 1958. In 1925, states that two particles of a certain class called fermions, and otherwise known as electrons, neutrons, and protons can never be in the same energy state. For example, two electrons with the same quantum number can't occupy the same atom.
What is the heat index?
Our bodies dissipate heat by varying the rate of blood circulation. Losing water through the skin and sweat glands and, as a last resort, by panting when the blood is heated above 98.6 degrees Fahrenheit. 37 degrees centigrade, the average body temperature. Sweating cools the body through evaporation. You can get the same feeling when you put alcohol on your skin. Because as the alcohol evaporates, the skin is cooled. The heat index, high, is an index that combines air temperature and relative humidity to estimate how hot it actually feels. It is based on a mathematical concept called the heat index equation. A long equation that includes the dry air temperature, relative humidity in percent form, and many biometeorological factors too long to list here. The resulting heat index table represents the apparent, or feels like, temperature. For example, if the air temperature is 90 degrees Fahrenheit, with the relative humidity at 60%, it will feel like 100 degrees Fahrenheit.
What was the first civilization to use a decimal system of weights and measures?
Between 2500 and 1700 BCE, the Harappa, or Harappan civilization of the Punjab, now a province in Pakistan, developed the earliest known decimal system of weights and measures. For more about decimals, see Math Basics. The proof was first found in the modern Punjab region, where cubical, some say hexahedral, weights in graduated sizes were uncovered at Harappa excavations. Archaeologists believe that these weights were used as a standard Harappan weight system, represented by the ratio 1:2:4:8:1632:64. The small weights have been found in many of the regional settlements and were probably used for trade and or collecting taxes. The smallest weight is 0.8375 grams, 0.00185 pounds, or as measured by the Harappa, 0.8525, the most common weight is approximately 13.4 grams, 0.02954 pounds, or in Harappa, 13.64, the 16th ratio. Some larger weights represent a decimal increase, or 100 times the most common weight, the 16th ratio. Other weights correspond to ratios of 0.05, 0.1, 0.2, 0.5, 1, 2, 5, 10, 20, 50, 100, 200, and 500. There is also evidence that the Harappan civilization had some of the most advanced length measurements of the time. For example, a bronze rod found at an excavation was marked in units of precisely 0.367 inch, 0.93 centimeter. Such a measuring stick was perfect to plan roads, to construct drains for the cities, and even to build homes. An ivory scale found at Lothal, once occupied by the Harappan civilization, is the smallest division ever recorded on any measuring stick yet found from the Bronze Age. With each division approximately 0.06709 inch, 0.1704 centimeter, apart.
How do functions pertain to sets?
A function in sets pertains to a correspondence between two sets called the domain and range. Each member of the domain has exactly one member of the range. It is often called a many-to-one, or sometimes one-to-one, relation. For example, f equals 1, 2, 3, 6, 4, minus 2, 8, 0, 9, 6, is a function, with each set of numbers being an ordered pair. This is because it assigns each member of the set 1, 3, 4, 8, 9 exactly one value in the set 2, 6, minus 2, 0, 6. It never has two ordered pairs with the same x and different y values. In this case, the domain is 1, 3, 4, 8, 9, and the range is 2, 6, minus 2, 0, 6. To show an example that is not a function, f equals 1, 8, 4, 2, 3, 5, 1, 3. 6, 11, is not a function because it does not assign each member of the set exactly one value, it assigns x equals 1 to both y equals 8 and y equals 3, or it has two ordered pairs that have the same x values to two different y values, 1, 8, and 1, 3. For more information about functions, see algebra.
What are events in probability?
Probability is a branch of mathematics that assigns a number measuring the chance that some event or any collection of outcomes of an experiment will occur. It is a quantitative description of the likely occurrence of the event, conventionally expressed on a scale from 0 to 1. For example, a very common occurrence has a probability of close to 1, an event that is more rare will have a probability close to 0. In more common usage, The word probability means the chance that a particular event, or set of events, will occur all on a linear scale expressed as a percentage between 0 and 100%. An even more detailed way of looking at probability includes the possible outcomes of a given event along with the outcome's relative likelihoods and distributions.
What are some transformations in geometry?
A transformation that keeps a figure's same shape and size, but moves it to a new location, is called isometry. There are several common types of these transformations. Dilatation is the only transformation that does not create equal figures. It means to take a shape and make it larger or smaller, but keep the same proportions. In terms of a circle, a dilatation creates another circle with the same center, also known as a concentric circles. Reflection is similar to what we called a flip in elementary school mathematics, like the flip side of an object. One easy way to see this is by noting one's reflection in a mirror. The figure is on one side of a line and the mirror image on the other. Reflection twice about two parallel lines is synonymous with translation. Reflection twice about two intersecting lines is called rotation. Another type of transformation is rotation. This is simple to understand. In elementary school mathematics it is sometimes called a turn or spin. In this case, one point on a plane remains unchanged while keeping all the distances between the other points the same. Finally, a translation, or glide transformation, is similar to what is called a slide in elementary school mathematics. All the points in the plane move in the same direction and the same distance. Or, the figure slides in a single direction. Translation is also considered to be reflection twice across two parallel lines.
What is the story behind Archimedes in the bathtub?
Any of the most famous stories of Archimedes involves royalty. Hiero II of Syracuse, king of Sicily, wanted to determine if a crown, actually, a wreath, he had ordered was truly pure gold or alloyed with silver, in other words, whether or not the royal goldsmith had substituted some of the gold with silver. The king called in Archimedes to solve the problem. The Greek mathematician knew that silver was less dense than gold, in other words, silver was not as heavy as gold, but without pounding the crown into an easily weighed cubic shape. He didn't know how to determine the relative density of the irregularly shaped crown. Perplexed, the mathematician did what many people do to get good ideas: he took a bath. As he entered the tub, he noticed how the water rose, which made him realize that the volume of the water that fell out of the tub was equal to that of the volume of his body. Legend has it that Archimedes ran naked through the streets shouting Eureka! I have found it. He knew that a given weight of gold represented a smaller volume than an equal weight of silver because gold is much denser than silver, so not as much is needed to displace the water. In other words, a specific amount of gold would displace less water than an equal weight of silver. The next day, Archimedes submerged the crown and an amount of gold equal to what was supposed to be in the crown. He found that Hiero's crown displaced less water than an equal weight of gold, thus proving the crown was alloyed with a less dense material, the silver, and not pure gold. This eventually led to the hydrostatic principle, as it is now called, presented in Archimedes' appropriately named treatise, on floating bodies. As for the goldsmith, he was beheaded for stealing the king's gold.
How are angles measured in trigonometry?
Angles in trigonometry are measured using a circle on x and y axes, often called circle trig definitions. The radian measure of an angle is any real number 8, theta, see illustration.
Did the Babylonians finally use a symbol to indicate an empty space in their numbers?
Yes, but it took centuries. In the meantime, scribes would not use a symbol representing an empty space in a text, but would use phrases such as "the grain is finished" at the end of a computation that indicated a zero. Apparently, the Babylonians did comprehend the concepts of void and nothing, but they did not consider them to be synonymous. Around 400 BCE, the Babylonians began to record an empty space in their numbers, which were still represented in cuneiform. Interestingly, they did not seem to view this space as a number what we would call zero today, but merely as a placeholder.
What does a priori refer to in mathematical modeling?
The term a priori refers to the amount of information available in a system. Based on the amount of a priori information, mathematical modeling problems are often classified into white box, a system in which all necessary information is available, or black box, a system in which there is no a priori information available, models. Practically all systems are somewhere between the white box and black box models, thus. This concept only works as an intuitive guide on how to approach a mathematical problem.
What did David Hilbert propose in 1900?
In 1900, German mathematician David Hilbert, 1862–1943, proposed 23 unsolved mathematical problems for the new century. most of which only proved to bring up other problems. By the 1920s, Hilbert gathered many mathematicians called the formalists to prove that mathematics was consistent. But all did not go well as mathematical complications set in. By 1931, Kurt Gödel's incompleteness theorem dashed any more efforts by the formalists by proving that mathematics is either inconsistent or incomplete. For more about Hilbert, see Foundations of Mathematics.
What is the origin of the word algebra?
The word algebra comes from the title of the book Al-Jabr w al-Muka Bala by Persian mathematician Muhammad ibn Musa al-Khwarizmi, 783 c. 850, also seen as Al-Khwarizmi or Al-Khwarizmi. The book is roughly translated as Transposition and Reduction, in which he explains the basics of algebraic methods. For more information about the history of algebra, see History of Mathematics.
What is a vector?
A vector is considered to be an element of a linear or vector space. A vector is different than a point, as it represents the displacement between 2 points, not the physical location of a point in space. Vectors also define a direction, points do not. Vectors are usually represented by a line segment in a specific direction on a graph, with an arrow at one end of the segment.
What is a game?
A game is a recreational activity that involves a conflict resulting in gains and losses between two or more opponents. Although some games can involve one player acting alone. In general, all games must have a goal that the players are trying to reach, and the opponents must follow strict, formal rules that determine what the players can or can't do within the game. If any of the rules are broken during the game, it is often referred to as a foul or, at its worst, cheating. The study of games is also a branch of mathematics and logic that is called game theory. In game theory, games can be simple and solved with mathematics that result in a complete solution, result of the game. It also includes the analysis of more complex games, such as cards, chess, and checkers, and can even be applied to real-world situations in economics, politics, and warfare.
Why was Max Planck important to quantum theory?
Quantum theory, or physics, entails the emission and absorption of energy by matter and the motion of material particles. It is a special situation in which very small quantities are involved. when added to the theory of relativity in which great speeds are involved, both form the theoretical basis of modern physics. One of the most important aspects of quantum theory is the quanta. In 1900, German physicist Max Carl Ernst Ludwig Planck, 1858 to 1947, proposed that all forms of radiation such as light and heat come in bundles called quanta. These bundles are further emitted and absorbed in small, discrete amounts, thus behaving in some situations like particles of matter. For example, a bundle of light energy is known as light quanta or photons. Planck devised the equation, E equals hv, in which E is the amount of energy in a single particle. V is the frequency of the wave, and h is the constant now known as Planck's constant. It is interesting to note that some people divide physics using Planck's discovery. The term classical physics is often referred to as before Planck, while the term for modern physics is often referred to as after Planck.
Did the Egyptians eventually develop different numerals?
Yes, the Egyptians used another number system called hieratic numerals after the invention of writing on papyrus. This allowed larger numbers to be written in a more compact form. For example, there were separate symbols for 1 through 9, 10, 20, 30, and so on. 100, 200, 300, and so on, and 1000, 2000, 3000, and so on. The only drawback was that the system required memorization of more symbols, many more than for hieroglyphic notation. It took 4 distinct hieratic symbols to represent the number 3577, it took no less than 22 symbols to represent the same number in hieroglyphs, but most of those symbols were redundant. See illustration on p15. Both hieroglyphic and hieratic numerals existed together for close to 2000 years, from the 3rd to the 1st millennium BCE. In general, hieroglyph numerals were used when carved on such objects as stone obelisks, palace and temple walls, and tombs. The hieratic symbols were much faster and easier to scribe, and they were written on papyrus for records, inventories, wills, or for mathematical, astronomical, economic, legal, or even magical works. Even though it is thought that the hieratic symbols were developed from the corresponding hieroglyphs, the shapes of the signs changed considerably. One reason in particular came from the reed brushes used to write hieratic symbols. Writing on papyrus differed greatly from writing using stone carvings. Thus the need to change the symbols to fit the writing devices. And as kingdoms and dynasties changed, the hieratic numerals changed. 2. With users having to memorize the many distinct signs.
What are logical operators in truth tables?
Logical operators in truth tables include such words as and or, which are all represented by certain symbols. For more about logical operators in predicate calculus, see below. For example, and, also called the conjunction operator, is also referred to as a binary operator. It is one of the most useful logical operators, as in P and Q, represented by the symbols // or and. The or, also called the disjunction operator, is also a binary operator. As in P or Q, and represented by the symbols V and. The not, also called the negation or inversion, operator is known as a unary operator, and is represented by the symbols or. In computer programming, not is often represented by the. But note, not all logical operators seem to represent words the way we are accustomed to using them. And many times they seem to contradict their proper definitions. But in a truth table, the logical operator means what it means without the usual nuances of our English language.
What is a sequence?
A sequence is defined as a set of real numbers with a natural order. A sequence is usually included in brackets, with the terms, or parts of a sequence, separated by commas. For example, if a scientist collects weather data every day for many days, the first day of collecting can be written as x1 data, then x2 for the second day, and so on until xn, in which n is the eventual number of days. This does not mean that sequences only get progressively larger and smaller. Certain solutions for sequences include a mix of the two.
What is the law of total probability?
The law of total probability can be written as follows: the probability that an event A will occur, P, A, is equal to the probability that event A and event B both occur, plus the probability that event A and event B occur, or A occurs and B does not. Using the multiplication rule, this is written as P, A, equals P, AB, P, B, plus P, AB, P, B.
What is an indeterminate number?
As with many other fields, mathematics has terms that are sometimes confusing or overlapping. For example, it is interesting to note that there is such a number as 0/0, which is called an indeterminate number. But be careful, this is not the same as an undefined number. If an indeterminate number comes up somewhere, you never know the value for your specific case and you can conceivably give it any number of values.
Why was Gottfried Wilhelm Leibniz important to calculus?
German philosopher and mathematician Baron Gottfried Wilhelm Leibniz. 16461716, was a contemporary of Isaac Newton. He is considered by some to be a forgotten mathematician, being overshadowed by Newton. But his contributions to mathematics were just as important. In addition to many other contributions, he, independently of Newton, developed infinitesimal calculus and was first to describe it in print. Because his work on calculus was published 3 years before Isaac Newton's, Leibniz's system of notation was universally adopted, including the notation for an integral. In 1684, he published Nova Methodus pro maximise et minimize, item tangentibus, a work detailing differential calculus and containing the familiar d, or d/dx, notation, along with the rules for calculating the derivatives of powers, products, and quotients.
What are some examples of how early peoples counted?
There were several different ways that early civilizations recorded the numbers of things. Some of the earliest archaeological evidence of counting dates from about 35,000 to 20,000 BCE, in which several bones bear regularly spaced notches. Most of these marked bones have been found in Western Europe, including in the Czech Republic and France. The purpose of the notches is unclear, but most scientists believe they do represent some method of counting. The marks may represent an early hunter's number of kills, a way of keeping track of inventory, such as sheep or weapons, or a way to track the movement of the sun, moon, or stars across the sky as a kind of crude calendar. Not as far back in time, shepherds in certain parts of West Africa counted the animals in their flocks by using shells and various colored straps. As each sheep passed, the shepherd threaded a corresponding shell onto a white strap, until 9 shells were reached. As the 10th sheep went by, he would remove the white shells and put one on a blue strap, representing 10. When 10 shells, representing 100 sheep, were on the blue strap, a shell would then be placed on a red strap, a color that represented what we would call the next decimal up. This would continue until the entire flock was counted. This is also a good example of the use of base 10. For more information about bases, see Math Basics. Certain cultures also use gestures, such as pointing out parts of the body, to represent numbers. For example, in the former British New Guinea, the Bujali culture used the following gestures to represent numbers. 1. Left hand little finger, 2. Next finger, 3. Middle finger. 4. Index finger, 5. Thumb, 6. Wrist, 7. Elbow, 8. Shoulder, 9. Left breast. 10. Right breast. Another method of counting was accomplished with string or rope. For example, in the early 16th century, the Incas used a complex form of string. Knots for accounting and sundry other reasons, such as calendars or messages. These recording strings were called quipus, with units represented by knots on the strings. Special officers of the king called quipukamiaks, or keepers of the knots, were responsible for making and reading the quipus.
What is a ring?
A ring is an algebraic structure, some definitions say a set, in which two binary operators, addition and multiplication, in various combinations must satisfy either the additive associative, commutative, identity, and inverse properties. The multiplicative associative property, or the left and right distributivity properties. For example, the elements of one operation, such as addition, must form a group that is commutative, also known as an abelian group. The multiplicative operation must produce unique answers that have the associative property. These two operations are further connected by requiring the multiplication to have a distributive property with respect to the addition. This can be written as follows, with A, B, and C elements of the ring. AX, B plus C, equals, AXB, plus, AXC, and, B plus C, XA equals, BXA, plus, CXA.
What is a mortgage?
A mortgage is a method of using property as security for the repayment of a loan. It is based on a 14th century coinage of a Latin word meaning dead pledge. The interpretation was that the property was dead to the borrower if he defaulted on the debt, and the pledge was dead to the lender after the loan was repaid. For centuries, it's been figured out using mathematics.
What are open and closed sets?
Formally, an open set is one in which every element in the set has a neighbor in the set or does not include its boundary. A closed set is one that does include a boundary of a set, or one where some elements have neighbors not in the set.
What are the probability and odds of drawing a certain card from a deck?
The probability of an event is usually described as the chances for the event to occur over the total chances for the event to occur, chances for/total chances. In the case of a deck of 52 cards, the probability of drawing a king from the deck is 4/52 equals 1/13 equals 0.077, or 7.7%. As seen above, the odds, or the ratio of chances for to chances against, chances for, chances against, can be found by the formula, total chances equals the chances for plus chances against. Or total chances equals chances for plus chances against, or chances against equals total chances for. Thus, the odds of picking a king from a deck of 52 cards is 452 4, equals 448 equals 112.
How are the simplest angles classified?
Angles are usually expressed in terms of rotation, in which a full rotation is equal in most cases to a 360-degree circle. Half of a full rotation is called a straight angle. A quarter of a full rotation is called a right angle, 90 degrees. An angle less than a right angle is called an acute angle. An angle greater than a right angle is called an obtuse angle.
What is numerical weather prediction?
Numerical weather prediction is forecasting the weather using numerical models. Because of the complexity of the mathematics involved, not to mention the number of variables needed to predict the weather, all numerical model studies are run on high-speed computers. The computer solves a set of equations, resulting in a computer model of the atmosphere showing how weather conditions will change over time.
What is an array?
A mathematical array is a list of lists, or a rectangular arrangement of objects. It is a useful way of keeping a collection of things. Arrays are orderly arrangements of objects in columns and rows, with the objects most often being numbers. For example, the most common arrays are two-dimensional with a certain amount of rows and columns. In this case, this is a 2 by 3 array, rows are always mentioned before columns. The order of numbers and slash or elements in an array may sometimes, but not always, be significant, as it is in a matrix, see below.
What is a good example of a topological structure?
Good example of a topological structure is called the Mobius strip, also called the twisted cylinder. It was invented by German mathematician and astronomer August Ferdinand Mobius. 1790 to 1868, in September 1858, although he did not publish his findings until 1865. The strip was also developed independently by German mathematician Johann Benedict Listing, 1808 to 1882, who discovered it in July 1858. Although Listing published his findings in 1861, Mobius's name is used for the strip. This one-sided surface is easy to visualize. Take a long single strip of paper, give one of the two ends a twist. That gives the strip a half twist in its length, or a 180 degrees twist, then attach the two ends. Amazingly, you can verify that it has only one side. It is not possible to paint it with two colors. Even if you cut the strip in half, down the middle, you will still have a one-sided surface. In fact, ants would be able to walk on the Mobius strip single surface indefinitely. Since there is no true edge in the direction of their movement.
What is analytic geometry?
Analytic geometry is actually another name for coordinate, or Cartesian, geometry. A way to geometrically represent ordered pairs of numbers, or coordinates. The objects are described as n tuples of points, in which n equals 2 in a plane and n equals 3 in a space. Or 2 and 3 dimensions, in some coordinate system. Overall, analytic geometry allows mathematicians to determine the position, configurations, and separations of objects using algebraic representation and manipulation of equations.
What are some types of mathematical models?
Mathematical models are commonly broken down into numerical or analytical models. Numerical models are those that use some type of numerical timing procedures to figure out a model's behavior over time. The solution is usually represented by a table or graph. An analytical model usually has a closed solution. In other words, the solution to the equations used to describe changes in the system can be expressed as a mathematical analytic function. Mathematical models can also be divided in other ways. For example, some models are considered deterministic, or a model that always performs the same way for a given set of initial conditions, or stochastic, or a model in which randomness is present.
What is the variance?
The variance is the average of the squares of a set's deviations. It is used to characterize the spread among the measures of a given population. First, calculate the mean of the scores, then measure the amount that each score deviates from the mean. Finally, square that deviation, in other words, multiply it by itself. Add all of them together, then divide by the total number of scores.
What is applied mathematics?
Applied mathematics is not only concerned with using rigorous mathematical methods, but also applications of those methods. It entails a wide range of research in the worlds of biology, computer science, sociology, engineering, physical science, and many other fields, especially in the experimental sciences. In each case, applied mathematics is used by a researcher to more Thoroughly understand a particular application or physical phenomena. The many uses of applied mathematics include numerical analysis, linear programming, mathematical modeling and simulation, the mathematics of engineering, mathematical biology, game theory, probability theory, mathematical statistics, financial mathematics, and even cryptography.
What is the Gregorian calendar?
By 1582 the discrepancies in the Julian calendar were not interfering with timekeeping, but they were beginning to infringe on dates of the Church's ecclesiastical holidays. The powerful Catholic Church was not amused. Pope Gregory XIII, on the advice of several of his astronomers, decided to reposition days, striking out the excess 10 days that had accumulated on the then present-day calendar. Thus, October 4, 1582, was followed by October 15, 1582. To fix the extra days problem, the Pope made sure that the last year of each century would be a leap year, but only when it is exactly divisible by 400. That means that 3 leap years are suppressed every 4 centuries. For example, 1900 was not a leap year, but 2000 was a leap year. Today, the Gregorian calendar rules state that every year divisible by 4 is a leap year, except for years that are both divisible by 100 and not divisible by 400. Some countries eliminated the 10 extra days, starting fresh with the Gregorian calendar. But not everyone agreed with the new calendar, especially those who distrusted and disliked the Catholic Church. Eventually, by 1700 those who had not changed their calendars had collected too many extra days. In 1752, the English Parliament decreed that 11 days would be omitted from the month of September. England and its American colonies began to follow the Gregorian calendar, with most other countries following close behind. It is now the standard calendar used around the world.
Who was Baron Gottfried Wilhelm Leibniz?
A contemporary of Isaac Newton, German philosopher and mathematician Baron Gottfried Wilhelm Leibniz. 1646 to 1716, is considered by some to be a largely forgotten mathematician. Although his contributions to the field were just as important as Newton's in many ways. He is often called the founder of symbolic logic. He introduced the terms coordinate, abscisses, and ordinate for the field of coordinate geometry. He invented a machine that could do multiplication and division. He discovered the well-known series for pi divided by 4 that bears his name. And he independently developed infinitesimal calculus and was the first to describe it in print. Because his work on calculus was published 3 years before Isaac Newton's, Leibniz's system of notation was universally adopted.
Where did the pound, and its abbreviation, LB, Originate.
The origin of the word pound comes from libra pondo, or pound of weight. The common abbreviation for pound, lb, originated from letters in the Latin word libra, or balanced scales.
What is a puzzle?
A puzzle is a mathematical problem that produces a solution often in the form of rearranging pieces. Often geometric, or filling in the blanks, such as a crossword puzzle. Puzzles do not typically require superior mathematical knowledge, but many originate from more advanced mathematical or logistical problems. They also include board games, such as chess, and brain teasers.
What is the definition of a modern computer in today's sense of the word?
In general, and simply put, a computer is a machine that performs a series of mathematical calculations or logic operations automatically. Computer specialists often divide computers into two types. An analog computer operates on continuously varying data, a digital computer performs operations on discrete data. The majority of today's computers easily process information much faster than any human. The response, output, of a computer depends on the data input of the user, usually controlled by a computer program. A computer also can perform a large number of complex operations and can process, store, and retrieve data without human interference. There is a great deal of overlap for the word computer. In a more archaic sense, a computer is called an electronic computer, or computing machine or device. The more common expressions include data processors or information processing systems. But remember, there is a definite difference between a computer and a calculating machine. A computer is able to store a computer program that allows the machine to repeat operations and make logic decisions.
What is a polyhedron?
The word polyhedron comes from the Greek poly, meaning many, and the Indo-European word hedron, meaning seed. In geometry, a polyhedron is considered to be a three-dimensional solid that represents the union of polygonal regions, usually joined at their edges and having no gaps. Polyhedrons are classified as convex, or if you extend any side, the figure lies on only one side of the plane. For example, a pyramid and cube, a concave polyhedron is one that can extend on both sides of such a plane. For example, a form that exhibits concavity on one or all sides of the polyhedron. The plural of polyhedron is often seen as polyhedrons, but it is more correct to use polyhedra.
How much does air pressure decrease with altitude?
It takes mathematics to figure out how much air pressure decreases with altitude. Close to the surface, and due to the pull of gravity. The air pressure exerted by air molecules is greatest, around 1000 millibars at sea level. From there, it declines quickly with altitude to 500 millibars at around 18,000 feet, 5,500 meters. At 40 miles, 64.37 kilometers, it will be 1/10,000 th of the surface air pressure. This can also be interpreted another way, for altitudes of less than about 3,000 feet, 914.4 meters. The barometric air pressure decreases about 0.01 inches of mercury for each 10 feet, 3 meters. Of altitude, or a decrease of 1 inch of mercury for each 1,000 foot 304.8 meters gain in altitude. If millibars are used, it is 1 millibar for every 26.25 foot, 8 meter, altitude gain. That means if a person takes a ride in an elevator, hits the button for the 50th floor and coincidentally has a barometer in his or her pocket, the pressure would fall by approximately 0.5 inch, 1.27 centimeters, during the ascent. This also means that higher altitude cities have major differences in barometric readings. For example, the air pressure in almost mile-high Denver, Colorado, is only 85% that of cities that reside at sea level.
What is the polar form of a complex number?
The polar form of a complex number is equal to a real number expressed as an angle's cosine. And the imaginary number, I, times the same angle's sine, with the angle expressed in radians. For more about angles, sines, cosines, and polar forms, see geometry and trigonometry. This is seen in equation form as r cos 8 plus I sin 8, in which r is the radius vector, 8 is the angle, and I is the imaginary number.
What are economics and econometrics?
Economics is a branch of the social sciences that deals with the production, distribution, and consumption of goods and services, including their management. The application of mathematical and statistical techniques to economics and financial data is called econometrics. It includes the study of problems, the analysis of data, and development and testing of theories and models.